Today, we're going to talk about something that feels like it's straight out of science fiction, but it's happening right now. AI that can actually understand our emotions. It's got a name, effective computing. And believe me, it's poised to change pretty much everything about how we interact with technology. All right, let's get into it. I mean, just stop and think about that for a second. Really. What if your phone or your car or even an online course could tell if you are getting frustrated or bored or if you were totally engaged? This isn't some far-off idea anymore. This is being built as we speak, and it's all thanks to some incredible new breakthroughs. So, the official name for this whole field is effective computing. Basically, it's a part of AI that's completely focused on giving machines a kind of emotional intelligence. The end goal? To create systems that can pick up on our feelings and then react in a helpful way. Whether that's a smart tutor changing up a lesson plan for a confused student, or a car sensing that its driver is getting drowsy. So how on earth does it work? Well, the real secret sauce is something called a multimodal approach. This means the AI isn't just looking at one thing, like the words you're saying. No, it's looking at everything at once. Your facial expressions, the tone and pitch of your voice, and the words themselves. It then fuses all of that information together to get a way, way richer picture of what you're actually feeling. And using all those data streams isn't just a small improvement, it's a huge one. Research shows that these multimodal systems are, on average, 9.83% more accurate at spotting emotions than even the best systems that only use one source, like just video or just audio. Now, in the world of AI, a nearly 10% jump in accuracy, that is a massive, massive leap forward.
Okay, so that big performance jump doesn't come from magic. It comes from a really fundamental change in how the AI is built. We're going to pull back the curtain and look at the core engine that makes all this possible. It's a concept called attention.
And to really get why attention is such a game changer, you have to understand the problem it solved. See, the older AI models, like the ones you see on the left, had this major flaw. They would process information piece by piece in a sequence, and then try to cram the meaning of the entire sequence into one tiny compressed summary. And in that process, a ton of important detail just got lost. Researchers have a great name for this problem, the information bottleneck. Think of it like this. Imagine trying to summarize an entire 2-hour movie in a single sentence. You'd lose almost all the nuance, all the subplots, right? Well, that's exactly what was happening inside the AI. A tiny bit of sarcasm in someone's voice at the start of a sentence would get totally washed out and lost by the end. And this quote just nails the shift perfectly. The new way, the attention model, it doesn't compress everything down. It gives the AI selective access. So instead of forcing the AI to rely on a flawed, tiny summary, it lets the AI look back at all the original information at any time and pull out exactly what's most relevant for what it's trying to figure out in that exact moment. This whole process of paying attention can actually be broken down into a surprisingly simple 3-step method. It's often called the query, key, and value method, or QKV for short. And this little engine is at the very heart of the most powerful AI models we have today, like the Transformer. So here's a really simple way to think about it. The AI basically has a question. That's the query. It might be something like, what's the emotional tone of this specific word? It then takes that question and compares it to a whole library of all the available information. That's the keys. And based on which keys are the best match, it pulls out the most relevant pieces of content, the values, to build its answer. It's like a super fast, dynamic search and retrieval process happening thousands of times a second.
This table really makes it clear why attention is so much better. The old ways, like early fusion, just kind of mashed all the data together right at the beginning. It was simple, but not very smart. Then you had late fusion, where each data stream did its own thing and they just sort of voted at the end, but that missed all the important ways the cues interact with each other. But attention, well, that's the smart one. It dynamically learns when your voice is more important than your face, or vice versa, giving it a much, much deeper understanding of the context.
Okay, so let's make this real. How would this tech actually figure out a complex feeling, like, say, boredom? Well, it's not about finding one single clue. It's about recognizing a whole signature of clues that shows up over time.
And that's the key thing to understand here. You're not bored in a single instant, right? Boredom is a pattern. It's how your vocal energy might slowly decrease, or your posture changes, or you start to fidget more. The AI has to look at the data over a period of time to spot these trends as they develop. And here is that signature broken down.
Visually, the AI learns to see things like your gaze drifting away, a slouched posture, maybe you touching your face or hair. From your voice, it's hearing a flatter, more monotone pitch without much energy. And in your words, it might see you're not participating or just giving one-word answers. So when that attention mechanism sees all these different clues happening together across all the channels, bingo, it flags the state of boredom. But of course, this ability to decode our innermost states, it's a massive double-edged sword. And we absolutely have to face the fact that this technology isn't just powerful, it could also be incredibly dangerous. This really is the core dilemma of affective computing. The exact same system that could create a compassionate mental health chatbot or an amazing adaptive learning tool could, with zero changes to the underlying tech, be used to monitor employees' emotions, to create manipulative ads that prey on our vulnerabilities, or even to build scary social credit systems. So you can see this brings up some incredibly difficult ethical questions that researchers are really grappling with. You've got the obvious stuff like privacy. I mean, this data is about as personal as it gets, and the huge potential for misuse. But one of the most urgent problems that needs solving right now is the issue of algorithmic bias. Yeah, it's a known, serious problem. These emotion recognition systems, usually because of the data they were trained on, are often less accurate for anyone who isn't a young, white man. Study after study has shown higher error rates for women, for people with darker skin, and for older adults. And the huge fear is that if we deploy this technology as it is, it could just end up amplifying the biases that already exist in our society and lead to really unfair outcomes for people. And that all leads us to this final, really critical question. As we build AI that can read our facial expressions, our tone of voice, and our posture, we're also giving it the power to interpret them. So who gets to write the rulebook? Who decides what a smile actually means, or what a sigh indicates, or what boredom even looks like across all the different people and cultures of the world? That is the question we now, all of us, have to answer.